The next topic I want to talk about it is the root mean square value. And let's assume we have, before I talk about it, assume we have a couple of numbers. Um, mm, for example, I have x1, x2, um, x2, x3, and all the way to, for example, xn. Assume I have n numbers. Um, so if I want to calculate the mean value of them, what's the mean value? So I know that the mean value of the uh, uh, x, the mean of x, so mean of these data sets, uh, which we can, for example, call it, for example, the x of the mean or the average. Is basically we add all of them together. We add all the x together and divided by total number of that we have. Just add all together divided by the n. So we have n number, we add all of them, um, we will add them together. This is a very simple, so this is the mean of that. There is a similar concept with the mean of the x that is called the root mean square of x, and it's somehow like that. So if I go ahead and it says the RMS of x, so x usually they call RMS is going to be this time. You see, this time for the mean we add all of them, then divided by n. This time we add all the square root of them instead of add. So we add all the square root of them, and then divided by n. So in the mean we add the values divided by n. Here we add all the square root of uh, solid all the square of them, not a square root. We add all the square of them and then divided by n, and then we get the square root of that entire value, whatever it is. So this is going to be the root mean square. So basically we square everything, we get the mean of the square, that we get the root of that uh, value that we have. And I will tell you a little later why we do that. So this is if we have the number is sitting like that. So if the numbers are again here are if we have the number, if we know the numbers, so we have some values. So this is the first case that we have. The second case that we have is that assume instead of having the numbers or values, we have uh, the function. So we know the function. So assume we know uh, the function, and we know that function is something, whatever it is. So we know that function, and we know what is that function. If we have the function and we want to calculate the mean of the function, sometimes we might probably not have, for example, look at that much, but any function that we have, for example, I will write it here. If I say the ft, uh, here, for example, if I say the ft is sine, for example, uh, 5t or whatever, something like that. If I go ahead and plot that, so if say this is a ft and this is a t, if I go ahead and plot that, I know it's gonna look like something like that. And I know that if I take an average from that function, I know for the sine, the mean is gonna comes at 0 eventually. So if I do to calculate the mean for the function of the sine, is gonna comes out at 0. It's not gonna. So for the sine, it's gonna be 0. For the cosine, we know it's gonna be 0. For other function, there might not be 0. So how we calculate the mean of the function if we have it, instead of having it as an individual values, have it as a function. So mean of the function, if we want to say, how we do that. So I would say the f mean this time is going to be in form of that a little bit integration. So it's going to be well, let me see right here this time. So f mean is going to be 1 over t2 minus t1, and it goes from let me make it smaller so don't make it confused with the period. So it's going to be t2 minus t1, and then the integration of the going from t1 to t2 ft dt. This is how we calculate the mean of the function. So if you have, for example, the ft is the sine of that, for example, we just replace that in this equation and do the calculation, and we can find the mean of the function from t1 to t2. Similar to that, if we have, again, we have the function of the t, and we know, again, similar to that, if it's going to be like sine or cosine or any function, we can also calculate the root mean square of that function. And then the root mean square of the function, which, by the way, this is going to be a single value, and this is going to be also a single value, would be something like that. So it's going to be 1 over t2 minus t1, the integration of t1 t2 and f square root of t dt. So it's going to be the root mean square of that function. So this is the second format that we have. So either we have the values as a number, so we know the x1, x2, x3, we have the numbers, or we have the values as, for example, the function. So we can do the calculate the mean or RMS value, or mean or RMS value if there are, we know the values, if we know the numbers, or if we know the functions itself. This is how we do that. So how we can use that, why we actually need this is because if I go ahead and write it, usually let's go and, for example, we know the when it comes to calculate, for example, the power in the circuit, we know that the power in the circuit is just made of the resistance. For the DC, current, we know that the power is going to be V square divided by R. So this is what we have for when we have the DC current. Now, when we have the AC current, to get the average P, and why we say the average here, because here the V for the DC current, V is constant. But when it comes to the AC current, the V is not constant, it just keep changing over time. So here, what we have is that in the DC current, um, the V is constant. So that's going to be the V. So if it's the V and if it is the T. But when it comes to the AC current, then it's not going to be constant anymore. If you have the V and if you have the T, then it's going to be something like that. So then what V we are going to use when we want to calculate the, so this is the DC and this is the AC. So now that the V is changing over time, what value of V we are going to use here when we want to calculate the P. Here, then instead of using the V, which is constant here, we use the RMS value of that V to calculate the P. And the P value that it gives us is the average P, because if you look at here, the voltage keeps going up and increase and then goes down and becomes zero and then decrease and increase and decrease. So the P value is actually changing over time, but the average value is going to be equal to the RMS value here. The same here, also we will have it for another, for example, we know that for DC current, we know that the P, again, the power in this in the system is going to be the I square R. So this is what we know. Now for the AC current, again, the problem here is that the I is not constant anymore. The I is going to actually is changing. So I would say that the P is going to be function of time T, and then to get the average of that, we can go says the P average. I have to write it like this here, so I'm going to fix it there as well. Instead of using the I over time, we use the I. And I'm gonna use because the book used capital I, so I'm using that. But it's gonna be the RMS value of that I times R. So RMS value of that times R. The same here. Let me rewrite that here. So if it's the AC, we know that then it's going to be P is going to be the function of time, because the V is actually changing over time. And then to get the average of that, we use the VRMS divided by R. So in other words, anytime that, for example, we have the equation in DC current that we had it before, and we use it to calculate that. Now, if we want to find that values for the AC current, use the RMS value instead of the variable you have in your equation. So if you use the RMS value, what you are gonna get is gonna be the average of that. For example, for the power, we know that in the DC we have the voltage square divided by R. Now when it comes to the AC, instead of the voltage, we use the RMS value of the voltage. And if we use the RMS value, what we get is the average of the power over the time. But the same, here's the average of the power over the time. So that's what we use the RMS value for. And one more thing is that also cancel the RMS value for sine or cosine wave. is relatively much easier than what we had before. So let me go back here. I said if you have the function, this is what we are going to use to calculate um, um, uh, the equation, so the RMS. So if I go ahead here, if ft is not sinusoidal, then the RMS value of the ft is going to be, as I said before, is going to be the square root of 1 over t2 minus t1, the integration of t1 to t2 ft squared dt. So this is if it is not sinusoidal. What if ft is sinusoidal? It's like if it is cosine wave or sine wave, it's much easier to do that. Then the FRMS is equal to, for example, the um, if you have, for example, we have the F max divided by the square root of 2. So, for example, if if we have the Vt is going to be the V max cosine omega t plus theta, then the VRMS, the RMS value of this, because it's a sinusoidal wave, is going to be the V max, or basically the amplitude, divided by a square root of 2. So whenever you want to calculate the RMS value, first check it. If it is not the sinusoidal, so that's the way we have to do it. But if it is sinusoidal, just find the maximum of that sine or cosine wave and divide it by a square root of 2, and that's going to be your root mean square value. So if you have a question, please go ahead and ask. So let's look at an example. Assume we have the Vt is going to be 100 cosine 100 pi t. Assume our voltage is going to comes out from the equation like that in function of that t, and it's connected to the 50 ohm resistance, and we want to know that how is this. So if I, for example, I have the source here, so it's going to be the Vt, and it's going to be connected to the 50 ohm. So it's R 50 ohm, something like that. Then if I have the simple like that, I want to know what is the average power is used by this resistance that I have here. So I know that the average power is VRMS square root divided by R. So I have to go and find the VRMS. And here, look at I have the cosine wave because I have the cosine wave. So I know that because the cosine wave, so the VRMS is going to be the Vmax divided by a square root of 2. So the Vmax here is 100. So it's going to be 100 divided by a square root of 2. So that's going to be my um, VRMS. So therefore, I can say the P average, the average of the power is going to be used by that. It's going to be VRMS square divided by R. Therefore, it's going to be 100 divided by a square root of 2 squared divided by 50, which if you do the calculation, that's right, it should comes out at 100 watts. So that you can calculate the power. And if I want very schematically try to draw that. So this is the P average, that what we have here. So what about, let me just write it here, I'm not going to calculate, but what about the P over the time? So this is the average value of that. But if I want to calculate, draw a line here. So if I want to calculate the P over time, so the PT, what's the PT? So I know that the P over time is the VT squared divided by R. So this is what I'm going to have. And then if I substitute the value there, so I would say that it's going to be, this is the VT, so it's going to be 100 cosine 100 pi t squared divided by 50. And if you do the calculation, so eventually the PT over time is gonna comes out as 200 cosine square 100 pi t. So this is the t. So this is the average. This is what we have over time. And I'm gonna try to draw them schematically to give you some idea what's happening. So if I have the voltage here, it's going to be the T, that's going to be the voltage. Let's see how it's changing over time. I know that the voltage is changing like that, so it's going like that over the time. Oops. Something like that. So this is the how the T is changing over the time. Now, if I go ahead and try to draw the P over the time, I'll choose another color. And by the way, so when we do that, we know that, look at here, this is the cosine wave. So the maximum here is 100. So that is going to be here, is going to be 100. That's the maximum. So it's going to go there. Now we have this cosine wave, and it starts from 200. So this is a cosine wave starting from 200, and it has a if I can draw it, so it comes here to 0. So when it's 0, it goes from 200 to 0, and then when it's here, so it's going back to that maximum. When it's 0, it comes to 0 again. So when it's max, it goes back to max. goes back to 0. Well, goes back to 0 wherever it is 0, and when it's the minimum, so it's going back to max and 0 and max and 0 and max and 0 and max. It's look something is going to be look something like so. Wherever it is 0, it's going to be 0 here. Whenever it is maximum or minimum, it's going to be max here because it's going to be a square, and this is going to be 200. And then the average value of that is going to be this. So that 100 is going to be here. So that's the this one is P average, which is 100. So as you can see, um, that voltage goes from 100 up and down and up and down. But when you look at the P, because the P is the square, is only positive. It doesn't become negative, it's only positive. So it goes from maximum to 0, maximum to 0, maximum to 0. It never goes to negative. And then when you have the average value, it's going to sit right at the middle of this minimum, which is 0, and the maximum, which is 200 there. So that's what you have it there. If you have any question, please go ahead and ask. So let's look at another example, a quick example. What if this time, for example, we have the VT, but it's going to be like this. So it's going to be 3t and 6 minus 3t for if the t is between 0 and 1, and if the t is between 1 and 2. So assume this is the voltage we have, and we want to find the Vrms. So remember, if it is sinusoidal, we know that how to calculate it. If it is not sinusoidal, so if I go back, then what? If it is sinusoidal, so that's it. So V max divided by square root of 2. That's the Vrms. But if it is not sinusoidal, we will have to use this equation. So if you go there, look at that, it's not sinusoidal, it doesn't have sine or cosine. And actually, if you go ahead and draw that, you will see it will look like something like this. So just try to, so if it's the V and if it's the T, it actually looks like this. So it's go down, goes up, goes down, and goes up. It actually like, this is how it's look like. That's if you draw that. So it's not sinusoidal, because because it is not sinusoidal. So the Vrms that we want to calculate, we have to use the integration. So we have to go ahead and say that what we have is going to be the root square of 1 over t2 minus t1, and from t1 to t2 ft square root of that dt. This is what we have. So we want to start it between 0 and 2. We want to see what's happening between 0 and 2, and basically it's going to be 0. This point is going to be 1. This point is going to be 2. So this is what, in this case, what we want to happen, see what's happening between 0 and 2. So I go ahead and do that between 0 and 2. And if I go ahead, I would say that, so, okay, this one is going to be 1, and so I would write it like, so it's going to be 2 minus 0, and then I would break this into two integration, one between 0 and 1, one between 1 and 2. So it's going to be 0 to 1, and what's the ft is going to be 3t square root of the to the power of 2 dt, and then plus from 1 to 2, from 1 to 2, from 1 to 2 is going to be this equation, which is going to be 6 minus 3t dt, and then, so this is how we are going, because in a sinusoidal I have to use this, and because it's going between 0 and 1 and then 1 to 2, so I break it into two integral. And then if you can plug this into your calculator, or you can do it with hand, any way that you want to solve that, but probably the best way is that you learn to how to plug it into your calculator. Eventually this should comes out as, if I write everything right, it should comes out as square root of 3 volt. So one more time, because it's not sinusoidal, we will have to use this equation, and the rest is just mathematical how to do that integration.